Good morning, beta. Now I'm going to discuss about the charge to mass ratio of an electron. Charge to mass ratio electron first time was observed by Sir J. Thomson in 1896. Before this concept about the electron, we are supposing that the charged electron is massless particle. It means the charge is carried by those particles which can not have any mass. But by this formula we have proved that the charge bearing particle have mass also. It means now we are thinking that there is no particle having charge without mass. It means all particles having charge also has mass, but all particle having mass doesn't have charge. For example, न्यूट्रॉन एक ऐसा पार्टिकल है जिसमें मास तो है, मैटर है, लेकिन चार्ज नहीं है. बाकी प्रोटॉन, उसमें मास भी है तो चार्ज भी है. इलेक्ट्रॉन उसके पास चार्ज है तो उसके साथ मास भी अवेलेबल है. इससे पहले हम इसके लिए जो टर्म इस्तेमाल करते थे इलेक्ट्रॉन के लिए, वो हमारे पास होता था कि जो इलेक्ट्रॉन है वो कैथोड रेज है. जब कभी भी हम रेज की बात करते हैं तो रेज मीन्स एनर्जी लाइक. जिस तरह से हम गामा रेज कहते हैं तो गामा रेज में हमारे पास ये टर्म आ जाता है कि ये एनर्जी पार्टिकल है. तो बिफोर 1896 वी ऑल थिंक दैट charged particles are massless particle, but by this concept charge to mass ratio of electron we are now aware about it, that all particles having charge also have mass. In 1896 Sir J. Thomson used this pear-shaped instrument to detect the value of charge to mass ratio. In this case there are some particular points. First of all, there is term F. F means filament, which is connected with the source which provide heat, which heat is absorbed by this cathode plate. This cathode plate means negative charged plate thermionically emit electrons when it is heated by this filament. These released electrons can scattered here and there. ये electrons जो हैं वो multi directed हो सकते हैं, but these electrons are just unidirected by these two anode plates. Here A1 and A2 are anode plates, and typically they possess the value of potential. First plate has 1000 volt and the second plate has 500 voltage. So there is total potential difference for electron which provided kinetic energy or velocity in these electron beams. So that is 1500 volts. After this absorption of energy, all electrons become a beam which can easily move through these two plates by these holes. These electrons are projected towards the screen. Here is zinc sulfide screen. Zinc sulfide screen हम यहाँ पर क्यों use कर रहे हैं? Because it is produce a fluorescent effect when it is struck by charged particles, charged energetic particle. अच्छा, normally these electrons hit at this point O. If we are neglecting the value of magnetic field and value of electric field, means in the absence of electric field and magnetic field, this electron will hit screen at the point O. But if we provide the magnetic field, these graphs are indicating magnetic field which is inside the board. Its direction is toward the board, and P1 and P2, these two plates are actually electric field plates. Now if we are just considering the effect of magnetic field on the electron beam. So this electron beam is deflected in downward direction according to right hand rule. In right hand rule, we are stretching these fingers in the direction of field, and field is inside the board, and this thumb is always be indicated towards the direction of motion of proton. In this case, if the proton beam is there, so this proton beam will experience a force in upward direction, but in this case there is electron beam, hence it is deflected in downward direction and will project at this point at point O prime. So this particle now experiences a force of deflection by this electron, get an arc of an imaginary circle bearing a radius r. So now as we know that this deflecting force behave as a centripetal force. So we can write here, when a charged particle cross through a uniform magnetic field, it experiences a magnetic force which behave as centripetal force. फॉर एग्जाम्पल, अगर ये जो फोर्स है इसका हर जो पॉइंट है वहां पर हम देखें तो इसकी फोर्स जो है वो ऑलवेज acted in the direction of center of the circle. Hence we can write Fm is equal Fc. So this Fm is equal to Q Vb sin theta, and this is given by mv square upon r. In this case, note that the sin theta is the function, angle is between the magnetic field and velocity. So we are taking sin theta in this term. We cannot take the sin theta in this term because there is just one vector and its direction is not with any other vector. So here we cannot write sin theta term. In this case, this v term is cancelled by this square, and the remaining answer is for the charged particle, charge to mass ratio. If we replace this from m towards the q, then the b and sin theta move in this direction. So q upon m is equal to v upon rb. So if we provide theta is equal to 90, then we can write it as v upon rb is equal to q upon p. But if we take the q value as E for elementary charge which is belonging to the electron, so we can write it as also E upon m is equal to v upon rb. This is the simplest formula for charge to mass ratio for electron. If we put the known values of v, r and b, so we can conclude that E upon m for the charged electron is 1.75888 into 10 raised 11 coulomb per kilogram. This is the value of charge to mass ratio of an electron. This value is constant for electron. If we change the value of v, automatically the value of r and b r will also change, but the value of this whole factor remain constant, and that is 1.75888 into 10 raised 11 coulomb per kilogram. Now if we are going to find the charge to mass ratio of proton, so as we know that proton has a similar charge as of electron, but the mass of proton is 1836 times larger than the mass of electron. Hence, the charge to mass ratio for proton is 1836 times less than the charge to mass ratio of an electron. In this case, we are just find the value of charge to mass ratio V upon RV. But what is the value of V? What is the value of R? If we calculate drive the formula of velocity and radius, then automatically the value of your formula for charge to mass ratio will be changed. But the answer remains same, that is equal to 1.75 888 into 10 is 11 coulomb per kilogram. In next chapter, we are going to find the value of velocity and value of radius. So this is the first lecture for the charge to mass ratio of electron, in which we just derive this relation. In other lectures, we are finding there are two values of velocity and one value for radius. So it's a charge to mass ratio has also three more equations which are uploaded inshallah in next lectures. Allah Hafiz.